Hello class, let's begin with the solution, the full solution each problem for the exam type A, the midterm exam type A, which was the first that took place, the original one. And I'm gonna be solving each of these exercises for you in case you wanna investigate how they were done. So it's 9 problems. I'm gonna be making pauses in between, okay? And that's it. Let's just begin. So number one, two six-sided and fair dice, one blue and one red, are rolled. Find the probability of the following events. I give you about 7, right? Yeah, 7 events. I want you to find the probability of each one of these. Okay, how do we solve this problem? Well, fairly simple. What we do is first, well, let me write down problem number one. What we do is we set or we find or we calculate the sample space for this particular experiment, which, as we know by now, or we should know, is all of the all of these outcomes, right? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 2, 4, etc. until 6, 6. We have gone through this so many times that I don't need to explain why this is the sample space for this experiment. And then that's it. With the use of this, we can check each of the questions and try to answer them. The probability for the event A, both dice are 3. There is only one outcome favorable to this event, which is this one, right? This one is the only favorable outcome. So you have one favorable over 36 possible ones. Remember that this is a set of 36 elements. So that's it. Probability of A is 1 over 36. Not much to be done here. It's quite simple, you know. I mean, this problem, anyways. The probability of the event B, they are unequal. Okay, both dice are unequal. For example, this one, this is favorable. 1, 3 is also favorable, etc. So you can count them. You can count, like if you wrote the whole sample space, you can count which outcomes are the ones favorable to this event, and you're gonna realize that you get 30 possible outcomes out of 36, and therefore that's gonna be the probability. Another easier way to do it is basically consider the cases in which they are equal. For example, this one, this one, this one, this one, this one, and this one, right? 1, 2, 3, 4, 5, 6. In these cases, they are equal, and that is the complement of B. 6 possible cases over 36, but that is the probability of B complement. And since you're trying to look at B, then you know that this plus this must be 1, and that's how you get that the probability of B should be 30 over 36. That's it. Okay. Next, C. What is the probability that one die is a 1 and that the other is 2? Okay, then I can just write favorable outcomes are 1, 2 and 2, 1. That's it. I have only two favorable outcomes to this event, in which one die is a 1 and the other is a 2. You see? So it's 2 over 36. Done. Let's scroll down. D, both are even. Probability of D is the probability that both dice are even. Okay, how do we solve that one? Well, realize that the probability of D is equal as the probability of first die being even and second die being even. It's the same. Do you realize that? Okay, so since we are dealing with and I know that this event and this event are independent because the fact that the first die is even doesn't affect the probability of the second die being even. So this and this are independent. So basically the probability of D can be uh, understood as the probability of the multiplications. First die being even times the probability of the second die being even. And we know how to calculate each of these, right? It's just 1/2 for each of them. So that's it. The probability of D, both dice are even, is 1/4. E, the probability of the event E, which is their sum is even. Okay, in this case, what you can do is this. You can realize, let me erase this quickly. What you can do is you can realize that the sums of these outcomes, which are given in order, they go odd, the sum is odd, the sum is even, and then the sum is odd, even, odd, even, odd. You're gonna realize that if you put them all in order, you're gonna realize that it's one and one. Odd, I'm sorry, even, odd, even, odd, even, odd, even, odd. So it's clear that this must be 1/2 because there are 1/2 of this, which for which their sum is even. F, the blue die is a 2, given that the red is a 4. The blue die, let me erase this. The blue die is a 2, given that the red is a 4. Okay, in here what you have to realize is this, guys. This is a conditional probability, right? Is the probability that the blue die is a 2, given that the red is a 4. Okay, so this is the condition. But if you notice, guys, this has nothing to do with whether the blue die can be a 2 or a 3 or a 4 or whatever. It makes no difference. Imagine that I ask you, what is the probability that the blue die is 2, given that um, it's raining today? Given that it's raining today. Okay, this makes no difference. This is going to be the same as the probability of the blue die being 2. That's it. Whether this occurs or not doesn't change the probability of this. Okay? And so, why? Because they're independent, right? And so basically this is the same as the probability of the blue die being 2, period, which is 1/6. That's it. Done. And G, the probability that the sum of them is 5, given that at least one of them is 2. In this case, we also have conditional probability, but in this case, this condition does affect the probability of the sum of them being 5. Okay, so what do? You reduce the sample space, because that's what conditional probability does, right? You know that something is true, that at least one of them is a 2. That's what you know. This is true. And therefore, in regard to this new sample space, you're going to consider this probability. So what is my reduced sample space? If I know that one die is a 2, Then I have to pick from these original outcomes those that are favorable to such event. And they're going to be the following: 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. In this case, all of these outcomes are the ones in which the first die, or the blue die is 2. Now, what about the possibility of the red being 2? Well, 1, 2. And then many made this mistake. Many included this again. That would be wrong because you're already counting this particular outcome. It's already here, guys. So you shouldn't include this. You should include in the other column 1, 2, not this, and then 3, 2, 4, 2, 5, 2, 6, 2. You see? It's all of these 11, not this one. It's all of these 11 outcomes, which is your new sample space or your reduced sample space. It's all of this. You know that one of these has happened already. Let me erase this for, I don't want ambiguity. You know that one of these 11 has happened. Which one? You don't know. You don't know. All you know is that you know that one of these happened. Now, which of these 11 are the ones for which their sum is 5? Well, let's investigate. Not this, not this, this, not this, not this, not this, not this, this, not this, not this, and not this. So it's just 2. 2 favorable out of 11, and that's it. The probability of G is 2 favorable outcomes out of 11 possible ones. Why 11? And why no longer 36? Because you have a reduced sample space, because this is a conditional probability. And that solves this problem. Okay, now problem number 2. We have 2 events, A and B, and we have 3 pieces of information. We know that the probability of B is 0.2. We know that the probability of A given B is 0.4. And we know this other probability, the intersection of A and B prime, as being equal to 0.5. And then I'm asking you 4 questions. Find all of these things. So let's see. Problem number 2. Let me copy this information over here. I always like to do that. So how do you do this type of problems, guys? Well, trying out several things. You know the basic formulas for probability of conditional probability, right? You know the formula for the union, which is this. This is completely general. This always works. You know that if 2 events are independent, then this is true. If independent, a mistake that you keep doing. Many of you, I would say about 50% of you, made this mistake in this problem. You wanted to use this formula. Okay, why? Because I don't know. Okay, I told you, I've been telling you many times, you can only use this formula if you know that the events A and B are independent. Nowhere in this problem they tell you that the A and B are independent, and none of you, when using this equation or this formula, none of you told me I can use it because such and such, such and such and such, which means that A and B are independent. Nobody gave me any argument. You just wrote it down, and you wanted to use it. Wrong. I hope with this last time you can understand that you cannot use this formula unless you know that fact. And if you don't know that fact, just don't use it and do something else. What something else? I don't know. Get to think. Okay, so question A. Find the probability of A intersection B. Okay, so can I use this? No, no, because I don't know whether A and B are independent. I don't know that. At least not yet. So how do I find this? Well, let me use this thing. I know this, that the probability of A given B is 0.4. I also know that the probability of A given B is, by definition, the probability of the intersection over the probability of B. Okay? Now, since I have this value, which is 0.4, and since I have this value, which is 0.2, that's it, I'm done. Basically, all I need to do is replace, like so, and then just multiply. Multiply both sides by 0.2, and this is what you're gonna get. This is the solution to question A. Okay, next question B. Find the probability of A. Okay. Uh, okay. This is where this at this point is where most of a lot of you wanted to use that formula, the one I told you before about the independency of events. You wanted to use this formula because you thought, I guess, you thought I already have this. I already have this, and therefore I can calculate this. Wrong. Wrong. That's only possible if you know that A and B are independent, which at this moment you don't. So you cannot use that, and that was a mistake made by many of you. So what do we do instead? Well, let's see. Let's see what we can do. We can, for example, draw a Venn diagram representing the relationship between these two events. How do I know that they overlap a little bit in here? And how do I know that they don't look like this? How? Because of this, guys. Because of this. The probability of the intersection is greater than 0. Okay, so there is overlap. What that means is that there is the possibility of both A and B happening at the same time, which is this part in here. You see, if this was the case, then this should be equal to 0. The probability of A and B should be equal to 0 in order for this case to happen. But since this is not true, then it must be like this. That's how I can know. Okay, so now I know at least the geometrical relationship between the circles representing event A and the circle or the area representing event B. Perfect. Now, what else do I know? What else do I know in regards to the areas in here? What am I looking for? I'm looking for the area of A. Remember that probabilities in a Venn diagram are shown as areas. In other words, the area of all of this circle is this value. This area is this value that I'm looking for. Okay, so all I need to do, guys, is observe all the probabilities that I have at this moment. This is this and this, and play with this visually or geometrically, and coming up with a way to calculate the area of A by making use of all of these other areas. That's the trick. That is the trick. For example, well, I know this. Let me write 0.08. This is the area of this particular section, A and B, this particular section. What else do I know? I know that the probability of B is 0.2, which is all of this stuff, all this area, all of this area. And that gives me that the area of this particular section should be 0.2 minus 0.08. The area of this particular section, this moon, this half moon, so to speak. So how much is that? That's going to be 0.12. 0.12. Okay. Okay, so I know the area of this bit. I know the area of this bit. If somehow I could get the area of this bit, I'm done, because I would be adding the area of this bit plus 0.08, and that would be the probability of A. Okay, let's continue. What else do we know? We know this other area. Look, the probability of A intersection B prime. A intersection B prime. Let me do that with yellow. A intersection B prime. What is that area, guys? B prime is everything that is outside B. Everything, just picture B, and B prime is all the area that is outside the circle. Well, let me try to do it. Maybe this is not going to look very well, but I'm going to try my best. So all of this area, all of that area is everything that is outside B. And what is A? Well, clearly it's this circle, right? All of the circle. And where do they intersect? They only intersect in this. Now let me do it with white. The blue area and the area corresponding to the circle A only intersect here. Okay, can you see that? They intersect only there. So basically this white area is actually this much, 0.5. You see? This white area symbolizes A intersection B prime, and they're telling me that such area is 0.5. And that's the area that I wanted to find. 0.5. That's the area that I wanted, or that I needed to find, because now I know that if I add 0.5 plus this little bit, then that's going to be the probability of the whole circle A, or the area of the whole circle A, which is going to be 0.58. This is the answer. The probability of A is equal to 0.58, and I got it reasoning through the Venn diagram. Okay, that's how I did it. C, the probability of A union B. Okay, so I know that this is equal by formula, and this formula is completely general. This is always true, always, no matter what type of relationship A and B have. This is always true. Okay, so do I have this? Yes, I just calculated this value. Do I have this? Yes. And do I have this? Yes. So it's just a matter of inputting the values. Like so. And the result is 0.7. After you do the arithmetic, this is what you get. And that would be the solution for C. Let's see if we can finish here. Now D. Find the probability of A given B prime. Let's see if by making, well, no, let me actually erase this part. By definition, this is equal to the probability of A intersection B prime over the probability of B prime, right? Okay, so let's see. Do I have this? Yes, we do have the probability of A and B prime. It's right here, 0.5. Do I have this? Not technically, but I can get it. It's very simple. If I know that the probability of B is 0.2, that means that the probability of B prime is 0.8. And I'm done. This should be equal to 0.5 over 0.8. And that's it. Remember, I told you that if you kept the solutions in this way, that is okay. I didn't want you to do arithmetic in the exam. So this is the solution. Whatever number this is, that's the solution. And E, determine whether A and B are independent. How do I do that? I investigate this. At this moment, I cannot write this. I cannot write it down. Like if you want to write this down, you have to be like cautious. Like, is this true? Is this even true? Like try to make some annotation in order for your observer, your reader, to understand that you're not affirming that this is true. You're questioning. You're questioning whether this is true. And after you do, well, we already have this 0.08. And after you input these two values, what is probability of A? 0.58. And the probability of B is 0.2, like this. Then you realize that this equation is not satisfied. This is not satisfied. This is false. What does that mean for A and B? What that means is that they are not independent because they don't satisfy this equation. And this equation is always satisfied whenever A and B are independent. And that's it. So this is not true. This is not true. Well, they are not equal. And that finishes the problem number 2. Let me make a pause, then we continue. Okay, number 3. Consider the following data set of positive integers. All of these numbers, guys, are positive integers, including A and B, where A is greater than B. The mode of this data set is 1, and the mean is 16 over 3, 16 thirds. Calculate A and B and find the median. Remember that I told you that this is not correct. I was asking for the median. Okay, so let me copy these numbers: 2, 5, 7, 3, 1, 9, 8, A and B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values in my data set. Okay, let me order my data set. Well, no, I cannot do that because I don't know yet how much is A and how much is B. How do I start investigating this problem? Okay, they tell me this. The mode is 1. The mode is 1. So that leaves, since I have a 1 in here, since all of these numbers are different, guys, 2, 5, 7, 3, 1, 9, 8, all of these are different, then what this statement means is that either A or B should be 1. Either A or B must be 1. Which one? We don't know yet, but at least one of them have to be 1 in order for the mode to be 1. Okay, so we know that so far. Either A or B must be 1. What other information do I have? I know this. that a is greater than b, and that all of these are positive integers. All of these are positive integers, or all of these are counting numbers. Okay, 1, 2, 3, 4, etc. And that leaves only one conclusion, only one possibility. What is the conclusion? The conclusion is that b should be equal to 1. Why? Because we already said that a or b must be 1. And it's impossible for a to be equal to 1. A cannot be 1, because if a is 1, okay, then uh, if I pay attention to this, I will be saying that 1 is greater than b, okay, and the only positive, I'm sorry, uh, that would mean that b is less than 1, which is impossible, because I told you that all of these numbers are positive integers, okay. B cannot be 0, for example, because 0 is not a positive integer. B cannot be -1 because -1 is not a positive integer, etc. So necessarily B must be equal to 1 in order to satisfy all of these requirements of the mode being 1 and A being greater than B. Okay, it's a little tricky, more or less, but that's the only conclusion that you can arrive at. It's a necessity. So we already know that B equals 1. How do I find A now? By making use of this. The mean is equal to 16 over 3. And what that means is that the addition of all these numbers, 2 plus 5 plus 7 plus 3 plus 9 plus 8 plus A plus 1, which is B, over 9 equals 16 over 3, right? And just make the whole addition. We get 10, 20, 30, 35, right? So it's 35 plus A over 9 equals 16 over 3, which is the same as 48 over 9. Am I right? 3 times 3 is 9. 16 times 3 is 48. Yes. And therefore, 35 plus A is 48, and therefore A equals 13. 13. I hope I'm not making a mistake. I think I did the whole arithmetic correct. 2 plus 8, that's 10. I forgot a 1. So this is 36, this is 36, and then this is 12. Yes, I knew I was making a mistake. So that's it. This is B, this is A, and that solves the first question. Now find the median of this data set. I mean, come on, guys, this is very simple. Just now that you know all the values, just arrange them in order from lowest to greatest and find the number in the middle. I mean, that's it. I'm not going to do that. Another pause, and we come back in a moment. Number 4, I give you a data set with these many numbers. Find all these things. Once again, this is extremely simple, guys. I mean, all of this is, these are 10 points which are a gift. The mode, just count. I mean, the mode is, I can do it even without, doing anything. The mode is clearly the number 1 with 3 frequencies, and the number 3 with also 3 frequencies. So the mode is 1 and 3. The mean, just add the number. I mean, if you did this, if you did the following, like just express 2 plus 5 plus 1 plus 1 plus 7 plus 8 plus 3 plus 9 plus 3 plus 3 plus 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is good enough. You don't have to do anything else. I told you that you could leave the results in expressed in operations like this. You didn't have to do the whole thing. But if you did, it's also perfect, right? The median. The median, just arrange them in order, find the number in the middle. Let me do that actually. I mean, that's gonna be 1, 1, 1, and then we have a 2. Was this a 7 or a 2? 7. So 1, 1, 1, 2, 3, 3, 3. Do we have a 4? No. But we have a 5. Do we have a 6? No. And we have 7, 8, and 9. So this is my set in ordered form. We have 11. So the median is the one right in the middle, which is this one. This number divides my whole data set into two equal parts. 5 numbers or 5 values on the one side, 5 values on the other side. Thus, the median is 3. And then the lower quartile and the upper quartile, Q1 and Q3. Okay, Q1. Q1 is the median of the first half, this half of the data set, which is the number 1, as you can see, because this divides this set into two equal parts. So this is Q1, and in here that would be Q7. I'm sorry, that would be 7. That would be Q3 for the same reasons. It divides this part, this section, into two equal parts. So this is 1, this is 7, and the problem is solved. These were 10 points, guys, for free, basically. Okay, once again, a small pause, and I come back. Next problem, section B. Problem number 1. Let's see. We have the following. This problem has a probability of 4/5 of being solved correctly by you. Your best friend from CDEP has a probability of 3/4 of solving it correctly. Calculate the probabilities of the following events. So let me write this down. Let me write the event M. And let me write the event F. The event M is the problem is solved correctly by me. M for me. And F, as you may be guessing, is the problem. Well, it's the same stuff. The problem is solved correctly by my friend. So M for me and F for friend. And the problem from the start is telling me the probabilities of these events. This is 4/5, and this is 3/4. Okay? And that's the whole context. And then they ask me a series of questions. Question A. Find the probability of event A. Both of you solve it correctly. Both of you solve it correctly. So that's what this A stands for. Both of you solve it correctly, which, if you think about it, is basically the same as this. The probability of me solving it correctly and my friend solving it correctly. This is the same as this. Okay, so if I can calculate this, I will be solving my original question. Now, how do I solve this? This is the probability of an intersection. can I make use of this formula? Can I say that this is equal to this, the multiplication of each probability? In this case, yes, I can. And I have an argument. I have an argument. What is the argument? The argument is that these two events, guys, are independent. Imagine that I give you a problem to solve for you and your friend. You are in the same room, in the same classroom, that means, and you just get to solve the problem. I mean, it's very difficult to think of, I mean, it's very difficult to think that if you solve it correctly, then that's going to have somehow an impact on the probability of your classmate or your friend solving it either correctly or incorrectly. It doesn't make any difference. For all purposes, you don't even know of each other. You see, I mean, there is no like a mental connection or anything, nothing like that. So these two events are independent, and therefore I can make this conclusion. This is equal to this, and that's the argument. And yes, you should make that argument as best as you can, right? I mean, maybe not in the way I did it, but make some argumentation in order for you to apply this formula. So basically, that's going to be equal to 4/5 times 3/4, which is 3/5. Done. B. The probability of B is neither of you solve it correctly. Neither. Neither. In other words, this is the same as the probability of you not solving it. You see, if M is the problem is solved correctly by me, then M prime is the problem is solved incorrectly by me. So I need this, and I need also this, that my friend didn't solve it correctly. So once again, since I already know that M and F are independent, then this is the same as the probability of M prime times the probability of F prime. What is M prime? Is 1/5. What is F prime? Is 1/4. And this is 1/20. Period. Simple stuff, if you know what you're doing. C. The probability of C. You solve it correctly, and your friend does not. Well, this is the same as M, me solving it correctly, and my friend not solving it correctly. Once again, these are independent events. Therefore, this is the same as this. Therefore, this is the same as this. And it's 1/5. That's it. D. At least one of you. Well, let me check. Let me check my solutions just in case. Yeah, so far so good. 3/5, 1/20, 1/5. Yeah, I don't want to make any mistakes. D. At least one of you solve it correctly. This is a little trickier. D stands for at least one of you solved it correctly. What does that mean? It means the following, guys. That means that either me solved it correctly, or my friend solved it correctly, or we both solved it correctly. You see, there are three possibilities. Three. At least one of you solved it correctly. That should make allowance for only me solving it, or only my friend solving it, or both of us. Both of us solving the problem. You see? It's a little trickier. Now, how do I solve this whole thing? What you do is this, and this is why I told you it's a little trickier. Well, actually, there's a better way to solve this one. At least one of you solved it correctly. Well, let me show you this, just because I want you to see it. I want you to see how it's done in this way, and then I'm going to tell you the easier way to solve this problem. Okay, so let's do it. We have a double union, okay, and what I want you to do is this. We're going to be using this formula. P of A or B is equal to P of A plus P of B minus P of A and B. If you notice, guys, this formula makes use of only two events. It's the union of two events. In this case, we have a double union, which is a much more complicated stuff. Okay, how do we do this one? What you do is this: section. First consider this event or this other event. You see, like just like we in here we have A or B. In this case, we have this or all of this. All of this. These are my two events, signaled by the blue underlining. And proceed to write the formula. So this is going to be equal to the probability of M plus the probability of all of this minus the probability of the intersection of this and this. So it's going to be this intersection, all of this thing. Like this, okay? And as you can see, it's all of this is quite complex. Now I'm gonna get into too much trouble trying to solve the problem in this way. It is perfectly okay, and then we can now. I mean, this is easy to compute because we already have it actually, and in here I'm gonna have to apply the same formula again. This one now with these other two events, this or this, and I'm gonna have to do that stuff over and over again, like many simplifications, and that's gonna be way too long. I wanted to show you this, but I don't think I have the time. Now let me erase the whole thing. There's a simpler way to solve this thing. Okay, look at the question. Look at the event. At least one of you solved it correctly. At least one of you. If I ask you about the complement of D, think about the complement of D. D is at least one of you solved it correctly. The complement of D, guys, the complement of D is neither of you, well, it is neither of you solved it correctly. That's the complement of this. ¿Sí? Es decir, o sea, D es al menos uno de ustedes lo resolvió correctamente. El complemento de D sería esto, que ninguno de ustedes lo resolvió correctamente. Eso es el complemento. Y si se dan cuenta, ya calculamos esto. The probability of neither of you solving it correctly, which is this one, B, 1/20th. Can you see? So basically, all we have to do is this. Since I already know that the probability of the complement of D is 1/20th, then I can get the probability of D, which is simply 19/20, because this number plus this number should be equal to 1. And that's it. That solves the problem. That solves the problem. I solve this problem by making use of its complement, because attacking it directly, like I was doing at the beginning, is perfect. There is nothing wrong. But there's going to be many, it's way too complex, way too complex. So you see, a change of perspective helps me solve this problem much easier, you see, by making use of the complement. So always try to play that card, okay, the complement card. Like if you're investigating the probability of D and you go like, well, it's too complicated to make it directly, think of whether you can use the complement of D. And if this is very simple to get, then get it And indirectly, you would be getting the probability of D. That's a much wiser approach. Much wiser. Is it correct though? Yes, there is. Um, Suppose I have finished checking your exams and I realize that at least one of you two solved the problem correctly. What is the probability that you solved the problem correctly? Okay. So the probability of E is the following. The probability of me solving it correctly, given that at least one of us solve it correctly. And what that means is this event, M or F. The probability of me solving the problem correctly, given that at least one of us solve it correctly. And that phrase, at least one of us solve it correctly, should be specified by this. This event, M or F, means that either I or my friend or both solved it correctly. Okay, so this is the event that represents this phrase right here. And then I just stick to my formula. P of some event given some other event is going to be equal to the probability of the first event intersection the second event over the probability of the second event, like this. Okay, do we have this? The probability of M or F? We do, right? We already. Well, no, I don't. Both of you, neither of you. Okay, it's this one. At least one of you solved it correctly. It's D. And D is 19 over 20. So I already have this. It's 19 over 20. And then how do I find this? The probability of M and M or F. Okay. So I'm going to make use of my Venn diagram. This is M. This is F. What is M? M is all of this. And I'm looking for an intersection, so I'm gonna be looking for the intersection of this event and this other event. What is the area representing this event, M or F? The area representing such event is all of this. This blue area. This blue area represents M or F. And I'm looking for the intersection of this area and this area. What is the intersection between the yellow area and the blue area? As you can see, is all of this. That is the intersection. That is where both areas overlap, which is the same as M. You see that? So basically, guys, all of this, the probability of M intersection M or F is the same as the probability of M, according to the Venn diagram. So what is the probability of M? That's going to be 4 over 5. And that's it. This is my solution. Whether you simplify it or not makes no difference. It's 4/5 over 19 over 20. That solves the problem. So that's it. This is the problem number 1. Another pause, and then we come back.